Hi everyone, and thanks for joining us today in what promises to be an interesting look at LimitState Ring 4, which is the latest version of our Masonry auto analysis software that we're launching here in today's webinar. I'm Tom Pritchard, and I'm joined today by Matthew Gilbert, LimitState ND, and the driving force behind LimitState Ring. He'll be your guide through some of the many new features of the software and enhancements, and demonstrating these through a number of practical examples. It's really gratifying to see that we have over 250 people signed up for this webinar, because it shows just how much interest there is in ensuring that our Masonry Arch bridge stock is well understood and maintained. Today's webinar is going to last about half an hour, and there'll be some time scheduled at the end for questions, which you can submit in the Q&A functionality at the bottom of the screen in front of you. As there are a lot of people here today, then time is going to be limited. We might not be able to answer all the questions that we get sent, but we will make sure to follow these up with everybody after the event. So I won't keep you waiting, as I'm sure you're all interested to hear about the developments that have gone into the software. So without further ado, I'm pleased to hand you over to Matthew.
Thanks very much, Tom, and thanks everybody for joining us. I can see there's already a question in the Q&A. Will this webinar be recorded? And the answer is yes, it will be recorded. So if you do need to leave at any time, you can catch up with what you missed. Okay, so I'm just going to move on to the presentation. So first of all, say a few words of introduction. Firstly, about LimitState, who we are and what we do. We've been around since 2006, and our mission is to provide engineers with easy-to-use software that principally uses state-of-the-art optimization technology to provide solutions. And we have many hundreds of organizations using our software in more than 30 countries worldwide. A few words about masonry bridges. As most of the people on the call will appreciate, these are essential parts of transport infrastructure of this country, the UK, and many other countries around the world, despite the fact that they're typically well over 100 years old now. Clearly, we need to assess these rationally and take advantage of the capacity that they have, but obviously not overestimate that erroneously. So what's LimitState Ring? Well, it's interactive software for the analysis of masonry bridges. It uses optimization to automatically find the critical mode of response, whether you're dealing with a single, multi-span bridge, whether the failure mode involves hinging, sliding, and all sorts of different possible modes of response. In terms of driving a mode of response, you can either apply a live load, which is multiplied up until you get failure, or you can actually apply support movements to cause a mode of response that way as well. Where does the software fit in? Well, really, we designed the software to offer the simplicity of traditional hand methods, but with much of the power of advanced tools such as finite elements and discrete elements and so forth. So in that respect, you can, for example, in LimitState Ring, set up a model very quickly and easily, but you can, if you need to, for example, model the locations of defects that you observe in the field in the software. Its history stretches back 3 decades now, with the latest version 4, as you can see, some years in the making. So what's new in version 4? That's probably what you're all interested to find out. Well, previous versions of the software have already been quite feature rich. So one of the areas we focused on is actually improving existing functionality, taking on board feedback from engineers, users of our software. So that's been a key part. But there are also quite a few new features as well, which add to hopefully the usefulness of the software when applied to bridges in the field. In terms of the main features of the software, whether we're talking about ring 3 or ring 4, the key thing is that we can, when we're dealing with a live load, we can compute the margin of safety. So that's we call an adequacy factor applied to whatever vehicle loading you've got on your structure. What is the adequacy factor at collapse? And then using optimization software as optimization algorithms, as I mentioned, to automatically model a whole range of different scenarios. But without further ado, I'm going to dive in and have a look at some of the new features of the software, and focus on a number of key changes compared with previous versions. So one area that we've focused on is how vehicles are modeled. And if I just move and start up the software. So first thing you'll see is, if you're familiar with using previous version software, is that we have a different dialogue appearing on the screen. We have an option to use the wizard, which is what we've currently had in the past. But there's also a couple of new options. The template functionality we'll cover in the next webinar in early December. And later on today, I will talk about the DXF or CAD import functionality. But for now, I'm just going to use the familiar wizard to set up and solve a problem. And this is really the mode of response, which is designed, sorry, the mode of usage, which is designed to sort of compete with really simple tools. So you can quickly get a model of a bridge into the software and some analysis results out. So first few screens look relatively similar to the previous versions that have more functionality, for example, the ability to model fill behind abutments. But for now, I'm going to just set up something quite basic that's going to allow us to have a look at the new handling of vehicles. I'll set up a multi-span with, for example, a pier that's intermediate pier of 3 meters height, and I'll set up some backing over the pier of, say, 600. I'll click next, move on through. By default, the second span is the same as the first span. Right abutment, we're not going to model explicitly. Fill profile, clearly, in reality, we would have values for this, but for now, I'm going to keep the defaults. Partial factors, there is an obvious difference in this dialog compared with previous versions. We now have partial factors for ultimate limit state and permissible limit state. We also have a number of additional partial factors that we can use, basically designed to sync with codes of practice. For now, I'm just going to focus on the ULS, so I'll keep that as the defaults. Actually, the default was now is to have an axial load factor of 1.5, which is quite common. They used both now in the Eurocodes and also in the national highways in the UK, for example, codes. And then moving on to define the material properties. This is similar to previous versions, so I won't dwell on this. Masonry properties, backfill properties. There are some more advanced options. I haven't got time today to go into those. Hopefully we'll be able to do that next time. Surface fill, and then moving on finally to the load, which is the area that I wanted to focus on. So by default, we've got 100 kilonewton axle, but clearly if I'm assessing a bridge in the field, then I'm very likely to want to, for example, use vehicles described in codes. So for example, I could import from our database a vehicle, a single axle vehicle, in this case from CS454. And once that's in the project, I can then select from it and I can click finish. And I now have basically a bridge with an axial load, and I've got a green button here. And if I click solve there, then I get a solution. And we can see that in this case, with the default loading position, I get an adequacy factor of 3.54. Now, before I go on to the vehicle details, I'm just going to perhaps model a detail of this bridge, which I wasn't able to replicate in the wizard. So what I'm going to do is, for example, enter the presence of some weak masonry. Perhaps they've got a different construction near the top of this pier. I'm going to say that the crushing strength of that masonry is, say, 2 rather than 5. And one of the problems with previous versions of software is, once I've done that, it's invisible. The feature of the new version of software is I can actually now go up and I can choose to actually color the contacts by crushing strength, for example. So it's very clear that a change has been made. If I click solve now, actually the adequacy factor hasn't changed at all because this isn't in a critical location, so it stayed at 3.54. But if I go back to the load dialog, there's actually been some changes compared with the previous version. So I've got this single load position. To replicate what we had in version 3, I've got a sequence option. And basically what that allows you to do is to basically apply the same loading at increments along the bridge. And I can specify how many increments of spacing 300 I want. So that's how we would have done it with version 3. With version 4, we've got an auto option, which basically will simply move the vehicle across the bridge, and it will give me some indication as to what the critical position is for that. So we can see that the critical position is at 2263 millimeters, and now the adequacy factor is significantly lower. It's 2.396. And if I want to, I can zoom in, and I can see, that actually there's some positions close by where the adequacy factor was very close, within 1%. And then if I zoom out, there's some positions where perhaps it's less critical. So we can very easily, with this approach, see how the position influences the adequacy factor. If I have multiple scenarios, then multiple scenarios will be shown on this plot. Okay, so that's handling vehicles. Another issue when it comes to loading is bridge owners really observe ULS failures. What they do quite commonly observe is that a change in loading regime might cause a bridge that previously been in good condition with no problems, cause that bridge to degrade quite rapidly. And the danger then of that bridge becoming unserviceable. So one thing that we've provided in version 4 is analysis of permissible limit state as described in Syria C800. That's a free document. So if you Google Syria C800, you can download that freely from the Syria website. And for UK participants, that document is now recognised by CS454, and the methodology described is allowed to be used for assessment of UK highway bridges. More on that in the next webinar. In terms of actually what the calculations look like, actually it's the same calculation engine that we're using for the ultimate limit state. The key thing is some of the inputs of the calculation are changed. So in simple terms, and this does oversimplify it, more details in the next webinar, we neglect passive restraint because in reality would require large structural deformations to generate those, and we can't sustain those time and time again. And similarly, we use reduced masonry strength as the peak strength can't be mobilized time and time again. So if I go back to my previous bridge, to do a PLS analysis, all I need to do is change mode from ULS to PLS and click solve, and basically it's going to do exactly the same as it did before, but now with these new properties, and tell me what my PLS load factor is. So we can see that previously the adequacy factor was, I remember now, it was 2.396. It's now 2.52. 523. So it's actually 525. It's very similar in this case. However, the mode of response is different. So now we've got a single span mode of response being identified as critical. And potentially, depending on the bridge, we could find that the PLS is more critical than the ULS. More details on this in the next webinar. So the next thing I want to focus on is modeling more complex geometries. Masonry bridges come in a whole range of different shapes and sizes. Got the very, very complicated ones on the left here. We've got internal arches, something a little bit more basic on the right-hand side, perhaps something in the middle here, where we've got a relatively modest span, 8 and a bit meter span with cylindrical openings. And certainly we can use current generation tools to approximately model this kind of bridge. However, with LimitState Ring 4, it's going to be possible to model this in a bit more detail. So if we go back to the software, actually, before I go to the modeling that latter bridge, what I'm going to do is just show you one of the changes we've made to the wizard to make it a little bit more easy to model some of the scenarios that you see commonly in practice. So for example, if the springings at a pier head don't coincide, then we can very easily take account of that. So let's suppose, and I've got a 500 millimeter difference between the springing of the left span and the right span. And let's then suppose that the rise of the right span is a bit lower, again by 500, and click OK. And so now basically we've got what you quite commonly see in the field, which is this this type of construction. It was possible to model this with the previous version, but it was considerably less easy to do than it is in the current version. And once again, I can solve this problem. It's now asymmetric, so you can see it's definitely favouring the left span compared with the right span. So the right span, it's around 2.7, 2.8 for the adequacy factor, whereas on the right span, it's gone down to 1.76. So you can certainly model some geometrical complexity with that approach, but if we want to do a bit more, then we can use this CAD input functionality. So now I'm going to choose DXF, and initially then you're given some instructions as to about how you prepare your CAD model. What we don't want is all sorts of extraneous details that you might find on a typical engineering drawing, causing problems. So if you follow these guidelines, then you should find that you're able to import a geometry successfully. So the wizard then has similarities with the previous one, but in terms of the geometry, we're now browsing from a file. Got some instruction, also a log basically of how we've got on in terms of importing it. So it's imported some lines and objects. And now what I need to do is actually tell the software which object is which. So we're not using AI as yet, so we need to have some help from the user to identify, for example, areas where the fill is. In this case, we've got openings that we don't want to cause problems, so we can select those as openings. And finally, we need some supports to be specified. So we've got some supports. I've accidentally selected the wrong thing. So what I will do is I will clear the supports, and I will try again. So try again. Okay. And now we've hopefully got what will be an acceptable representation of the bridge. And then the rest of the wizard is as before, so I won't go into details. I'll just click finish. And so now we've basically got a model of the bridge. I'll click solve, and basically we can see how this bridge behaves. I'm currently on drag and solve mode, but I could be on use the automated learning as well. So you can see that we can model, this quite complex geometry and get results using the LimitState ring. In this case, the reality factor is around 2.7, 2.3 in the areas that I've probed. Okay, so that was this particular structure. That's probably all I've got time to focus on today. There's lots more features or enhancements. There's a new feature, command line mode, so we can, for example, assess a whole series of bridges on a particular route in one go, and then a whole series of other features which we hope you will find useful. So what I'm going to do now is hand back to Tom, who's going to talk about the availability of the software.
Thanks, Matthew. So current customers, you'll receive version 4 licenses and download details on the day of release, which is next Monday on November the 20th. For people who aren't current customers with a license, you can, on the same day, go and download the software and use it in free mode, which will give you access to the majority of the features of LimitState Ring 4. The main thing is that it won't report a numerical adequacy factor for you. However, if you did want to evaluate the software, then if you get in contact with us via email on sales@limitstate.com, then you can request a free full short-term license in order to do that evaluation. And as I mentioned, the public download will be on the 20th of November, and you should be able to get it from LimitState.com. So we've got a little bit of time for questions. So if you want to put them in the Q&A, we'll take them as many as we can on turn. The first one, so we already have a license for Ring 3. Will our software be upgraded to Ring 4 with the same license, or will we have to purchase an upgrade? So if you've already got a valid license for LimitState Ring 3, then we will be in touch with a new license for you in the forthcoming days. At no cost. Yeah, and it will be at no cost, yes. Are you able to model multiple spans with different springing levels? Well, hopefully that question was answered during Matthew's presentation there. So yes, you can do it in a variety of different ways. So you can either do it within the wizard and using the offset springings, or you could introduce it in a DXF file. We have another question. What does an adequacy factor of less than 1 for PLS imply?
So that implies that whatever loading you're applying to the structure is likely to lead to long-term damage, which will, in time, lead to the bridge becoming unserviceable. So if you're only traversing 1 or 2 vehicles of a particular magnitude, it may not be an issue. But if you're for example, exceeding the PLS when you have an industrial estate with HGVs crossing, many times a day, then you're likely to see damage. That's the hope that the PLS will allow us to be a bit more discriminating than we've previously been able to be. So the question, can openings in the piers also be modeled with the CAD functionality? Then potentially you can model anything. However, I think when you're talking about openings in the piers, you might be talking about a different direction. So in that case, what we would recommend you do, because the current version of LimitState Ring is a 2-dimensional tool, that you actually select blocks in a particular area and you change the unit weight of them. We're not going to be able to model any 3-dimensional modes of response associated with longitudinal openings in piers. So we've got a number of questions coming in. So let's find the next one. Importing CAD is a great feature. Will there be any future updates to allow the model the bridge in 3D, which will better incorporate the skew? We're currently, well, I have two hats. I'm involved in LimitState. I'm a director of LimitState. I'm also professor at the University of Sheffield. We've got an active research project at the university where we're looking at 3D modes of response, and we've worked with LimitState, who have actually developed a pilot 3D version of the software. However, it's early days at this point to know whether that will deliver sufficient benefits to make it worthwhile. But we are working in that area, and it may be something that comes in the next few years. Question related to that, I guess, is the question: can you model skew? So the moment you would model skew using the guidance in the codes, which is not ideal. Question about PLS: is it an equivalent of SLS? We've thought long and hard about whether to call it an SLS or a PLS. I mean, normally with an SLS, we're talking about quite superficial effects, whereas the PLS, if the PLS is exceeded, then we are talking about degradation, which over time will reduce the lifespan of the structure. So it's slightly different. But if you're interested, have a look at the document I referred to, Series C800. I think we're probably going to have too many more questions than we're able to deal with. So I think, Tom, we're going to need to answer these questions offline. So if you haven't asked a question and we haven't had a chance to get to it, then we will be in touch in the next few days. As Tom mentioned, there's a large number of participants of this webinar, so unfortunately we're not able to answer everybody's questions live.
Just to cover some of the questions that we were unable to answer during the webinar. Can the software automatically apply the impact factor to the critical axle? The answer to that is that Ring can help identify the critical axle for impact loading in a semi-automated way. Simply set up a separate scenario for each of the impact axles and use the auto load type, and then Ring will determine the lowest adequacy factor over all of the scenarios. Secondly, can the PLS method be applied to railway underbridges? The answer to that is yes, it can, and there's an example of this in Series C800, and the functionality is fully supported in the software. On network rail standard loads included in the software, yes, we didn't have time to show this, but Ring includes railway load models from Network Rail, UIC, and others. Is there an option to enter bespoke loadings, for example, for checking out normal load vehicles? Yes, you can. You can define your own vehicles and even export them for others to use in their projects as well. And will the presentation slides be made available? Yes, we'll send a link with the webinar follow-up and also make the slides available through our website. So just like to say thank you to Matthew and thank you to everybody for attending today's webinar. As you can see, we're very excited about LimitState Ring 4 and we hope that you are too. So do be sure to visit the website next week and to get yourself a copy to download. As mentioned at the beginning, we'll look to answer the questions that we haven't answered in the Q&A just now. And we will also send an email out with a link to a recording of this webinar for people to watch back later on our YouTube channel. Matthew also mentioned this second webinar here. If you haven't already signed up for it and it looks like something that would be of interest to you, then yeah, please do visit that link there and sign up for it, and it's at the beginning of December. And we'll also include a link to it in the follow-up to this webinar as well, with the link for the recording. So finally, I'd just like to say thank you once again for attending, and if you do have questions, feel free to send them in, and speak to you again soon. Goodbye.